Hello, this is Alan Elliott, and this is SAS Essentials Mastering SAS for Data Analytics, 3rd edition. This is Chapter 10, Evaluating Quantitative Data. In this chapter, we'll be learning how to calculate basic descriptive statistics using PROC means, producing graphs using PROC means, and creating output using PROC means. We'll also be able to calculate basic and advanced descriptive statistics and analyze the characteristics of a set of data using PROC Univariate. Also, we'll be looking at how to create graphs using PROC Univariate. As usual, if you'd like to follow along with the examples, please download the files at this location. Let's get started. Begin. All right, let's look at section 10.1, using PROC means. Now we've seen PROC means used before, but now we're going to do a little bit of a deeper dive into the various aspects of PROC means. PROC means is useful for evaluating quantitative data in your data set, for creating simple summary reports. It can be used to describe quantitative data, that is numerical data, describe means by group, searching for possible outliers, creating simple reports, and producing some graphs. So the syntax of PROC means is as follows, and we've seen sort of how this works before, but we say PROC means, and then we have options, and then we have statistical keywords. Those are all optional things that we can include in the PROC means, and then they have a semicolon followed by statements. So again, we have options before the semicolon, then statements after the semicolon. Typical options would include data equal, a data set name, max des equal some value there to control the number of decimal places. No print to suppress output, maybe because we're going to just use PROC means to create another data set. Alpha equal to define our alpha level for confidence limits. Now this table shows you the statistics keywords. Now let me go back up just a minute. So notice here we have options and then statistics keywords. So these keywords come before the first semicolon. By default, if you see the ones in dark, max, mean, in, min, standard deviation, those are the default ones. So if you don't ask for any of these, then those are the ones that are going to be reported. Otherwise, you could type in any of these options and produce some list of options according to your exact needs. So these statistics keywords then come after the option, typically like data equal research here, and then mean, median, standard deviation. So you can see those are 3 of the statistics keywords here. So all I'm requesting is the mean, the median, and the standard deviation. So that instructs SAS to calculate those 3 values in our research data set. We can also set the confidence limit using the alpha equal, and again that appears as an option here before the semicolon. So here we have alpha equal 0.1 and the default is 0.05. Some common statements for PROC means includes variables, class, output. We've seen those in some previous examples, but the var statement lists the variables that you want to have included. The class allows you to separate the PROC means output into groups. Output allows you to output the means to another data set that you could use for some other purpose. The freak option we haven't seen specifies a variable that represents a count of observations. We're going to see that later, but if we have, instead of having a long list of numbers, maybe we know that there are 10 number 5s, 8 number 6s, 7 number 7s, and so forth. If we have that kind of data, we can tell it using the freak option. The by variable, again, allows us to instruct SAS to perform the data by group. It's a little bit different than the class option. We'll see a comparison here later. And then the where condition limits the output to whatever condition is listed in the where. For instance, where age less than 50. All right, so let's look at some of the commonly used statements for PROC means. First of all, a common invocation would be PROC means data equal my data. But then we can add the list of variables we want. So here in red we see n, mean, standard deviation, and so forth. That just added some optional statistics. Again, the n, mean, and standard deviation are before the semicolon, so those are the statistics added, whereas the var, sodium, and carbo follow the semicolon and create a var statement that lists the specific variables we want to have listed. So let's look at an example. Example 10.1. Open the file called ameans1.sas, and you'll see this code. And we'll notice here we're creating a data set called children, and we're doing PROC means in 3 different ways. The first way is just the simplest invocation, PROC means with a title and run. And since we don't have a data set listed, it's just going to use the latest data set, which happens to be children. The next one is PROC means, and max des equal 2, so we're limiting the number of decimal places, and then we choose specific variables, weight and height. And then the third one, we're going to do PROC means, again, max des. Now we're going to specify which statistics we want to use, n, mean, standard deviation, median, and then we also, a semicolon, and then we also list 2 variables to include in the output. All right, so here are the results. The first one we see is just the default. We see weight, height, and age, and notice here that the mean and standard deviation has a number of decimals in the output. That makes a very cluttered looking table. So the second one, what we've done is we've limited the decimal places to 2. So compare the first table to the second table, and you see that in the second table, all of the reported values there are only to 2 decimal places. So that makes a cleaner looking output. We also only have the variables we asked for, weight and height. And then the next one is, again, we're going to limit or specify the specific statistics we want. In this case, n, mean, standard error, and median. So again, you can see how we can arrange this output table to produce the statistics that we have in mind. All right, now let's look at using PROC means with the by and class statements. I mentioned this earlier, how they differ a little bit. So this is going to compare them. The first time we're going to look at using the by statement. So first of all, before we use the by statement, we have to sort the data. So we're going to do PROC sort, and again, it's going to use the latest data set. PROC sort by gender, and then run. And then PROC means by gender. So notice we have the by gender in both places on specific variables there. Now let's do it a little bit differently, where we say PROC means class gender. Now notice here I don't have to do a PROC sort first. Class gender, and then we're asking for the same variables. So let's see how that does. All right, and then we're going to see that output here now in example 10.2. A means 2, and I've already described all of these options here that we're choosing. And I think there's a little bit, we're only asking for the variable called weight gain in this, and feed type is the variable that we're going to group the data by. And again, the first time we're doing a sort, and then the by feed type both times, and then the PROC means class feed times the second time around. All right, so here are here's the output. The first time, using the by feed type, we notice here it produces 2 different tables. And we have feed type equal 1 and then a table, and then feed type equal 2 and a table. So this separates the results into 2 separate tables. Whereas the class option, where we say class feed type, actually puts everything in one table. So here we see feed type is a column, feed type 1 and 2, and all the results listed here. So it depends on what you're wanting to get out of the run, whether you want the by analyses separated by tables, or whether you want it all together in one table. Again, a difference is we have to sort it first in the first instance, and in the second instance we don't have to sort it first. Okay, now let's look at outputting statistics using PROC means. We've seen that there was an output option, an output statement that we could use. So let's see how that works. So we have the statement output, then out equal file name. That's the name of the file we're going to create from these statistics. We're going to have a statistics name, like the ones listed in table 10.2 we saw earlier. That's like mean or standard deviation or something like that. And then we have a var name. Now the var name is what we're going to call whatever the statistic is that we're outputting. So this is the code that we would use to do this. Here we have PROC means from some data. We're going to output to a file called time1mean. We're going to output the mean and call it T1. And we're going to use the variable time1. So this outputs the means of time1 to a data set named time1mean and gives it the SAS variable name T1. All right, so let's see how that works in example 10.3. So open up a file called ameans3.sas, and you see here we have the code that I just described with the output name here, and then we're going to print the results. Now, notice we're not printing the data from some data. We're going to do a PROC print on the data set that was created, out equal time1mean. So now data equal time1mean. So we're going to look at the data set created by PROC means. And so now I've actually output both the regular output from PROC means, as we see in the first table here. So we had 50 records, a mean of 21.268, and some other things. But then down below is the output data set that was created. So it's quite a bit different. In this case, we only had one observation because we only asked for one thing. We have a frequency of 50, and T1 is the name of the variable we created. Now notice T1 is 21.268, and look up at the top table, the mean is 21.268. So it created a new variable called T1 that is the mean of the variable that we created, T1 baseline. All right, that was sort of a summary of our overview of PROC means. Let's look at another way to create some simple statistics, and that is using PROC univariate. Now, PROC univariate provides a wider variety of statistics than PROC means, and it also has some additional graphs. So it's better suited to helping you discover important information about the distribution of each variable. For instance, is it normally distributed? Are there outliers, and if so, what are they? What kind of data distribution for the variables do we have? So a simplified syntax for PROC univariate is, and it obviously looks very much like PROC means, but PROC univariate with options and statements. So a typical kind of format for a procedure in SAS. All right, so this is just to show you what we can create. Here's an example of things that we could create in PROC univariate, some graphs that we didn't see in PROC means. So here we have a histogram of systolic blood pressure by gender and wound type. So notice at the top we have gender, female and male, and over on the side we have the injury type, either a penetrating or a non-penetrating wound. So we have two items in the columns and two items in the rows separated. And then within each of them we have some reported statistics, the N, min, max, and mean, plus a histogram with a fitted normal curve. So we can see how we can create that in PROC univariate. So let's step through this. First of all, let's look at some common options for PROC univariate, and they're going to be very similar to many PROCs, but I won't go over the ones that are very similar like data, but here we have CI basic. This requests confidence limits for mean, standard deviations, and variance based on normally distributed data. Alpha, we saw that earlier, we can adjust the confidence limits from the default. Here we have one called mu0 equal n. That's used if we want to specify the location parameter for a one sample t-test, and we'll look at that more closely in the chapter on t-tests. Normal is going to request a test for normality. We can request various kinds of plots, including stem and leaf, box, probability plots, and some other things. Again, there's a no print option if we want to suppress the output and send the output instead to an output statement. And we also have trimmed, which trims the top and bottom proportion of the data before calculating the mean. This can be used to eliminate outliers. So if you have a data set that has a few really weird low or high values that are maybe meaningless, you can trim it by some percent, like 0.1, 0.01. And then common statements for PROC univariate. The var statement we know, the by statement we know, we've seen the class statement, output, all of these are very familiar. The histogram statement is a little different. It produces a histogram of one or more specified values. So for instance, we could include the statement histogram and then variable or variable names and then slash some options, and we'll look at that in an example. And also the inset statement, which is going to put a box containing summary statistics in the graph that we saw earlier, that we can request some information be placed in that box with the graph, and we'll see an example of that also. Okay, so let's look closely then at the histogram statement. We have histogram and then whatever variables we want to use and then slash options. So for instance, histogram age slash normal would produce a histogram of age with the superimposed normal bell curve. All right, let's look at common options for the PROC univariate histogram statement. We can ask for the density curve, like normal or kernel. We can also specify colors. So notice there I have color equal green, width equal 5. The midpoint option allows you to specify the intervals for the histogram bars. Midpoints equal min to max by units, for instance. V-scale, this option specifies the scale of the vertical axis. So we can control that. The W-axis specifies the width of the histogram bars. The W-bar line specifies the width of the line around the bar. And then we can have in rows and in columns, which specifies the number of rows or columns in a matrix of histograms. And we'll see some of those as we move along with some examples here. Now we notice the color options. So again, these options, colors, can be found in Appendix A, but they appear here, for instance, in histogram age slash normal, and then within parentheses we can have color options and some other options as well that we saw, like width. All right, so let's look at common options for the PROC univariate color statement. So we can have color equal and name a color. We can have C-axis equal color, which specifies the color of the axis. Again, you can use the same colors and stuff that we mentioned earlier. Notice that C-axis equal red, for instance, there. C-bar line specifies the color of the line around the bars. C-fill is the color of the bars. C-frame specifies the background color within the frame. And C-text specifies the color of tick mark values and labels. All right, so let's before we look at any more examples in histogram, let me just make a statement here about the graphics. So for recent versions of SAS, you may have to turn off ODS graphics for the colors in PROC univariate histogram to work. They may solve this issue at one point, but if you run these examples that request color but the colors don't come out, then what you can do is before you do the PROC univariate, do an ODS graphics off, and then later do an ODS graphics on, and in my experience that allows the colors then to work. All right, now let's look at some common options for the PROC univariate bar statement, which we're going to look at in a minute. The bar, these are the bars in the histogram, but the bar width we can specify. We can specify a pattern code. Again, these are in Appendix A, so we can have some sort of crosshatch pattern, for instance, or completely filled. We can have a bar label, which places a label above the bar, so we can, for instance, put counts above each bar to be clearer about how many counts are represented by each bar. And then, as we mentioned earlier, there's this inset statement. And the inset statement puts a box containing summary statistics in the graph associated with various option statements there. And so the way it works is we have the PROC univariate, histogram age / normal, and then as a separate statement we have inset, and then a list of variables we want to have in our inset box. In this case, mean and standard deviation. Okay, let's look at some common options for the PROC univariate inset statement. So in this first example here where it says display statistics, we see that the inset statement simply has a list of 4 statistics we want it to display. And those then will show up in the box where we're having the, in this case, the histogram up here. We can also format those values. For instance, in this inset statement, notice here the mean and the standard deviation are given labels. And also the 5.2 is a format, so we can get labels and formats that also allow us to customize what's in the inset statement. We can also have a normality test by saying inset normal test or NP normal. If we ask for P normal, it reports the P value for the test of normality. So oftentimes we would ask for those together. The inset position is a map position, northeast, northwest, and so you can imagine what that means in the box. Finally, we can give the box a title. Here we have the inset and then the header equal and then sort of title. And also we can ask for no frame and the height of the characters in the inset box. All right, here's an example for us to try. Example 10.4. Open up the file called AUNI1, and we see here that we're reading in 50 values using the input age at. And then we simply have a PROC univariate data example var age. That's a very simple way to get the PROC univariate to work. And then we get a number of tables. This is just showing one of the tables. But here we have the moments, which gives us the N, or the number, mean, standard deviation, skewness, and so a lot of things that aren't given by default, at least, in the PROC means, coefficient of variation, and a number of other things. Now the statistics on the moments table, I'm not going to give you all of these, but you can look these up in the text, and if you're interested in some of these. But skewness and kurtosis, for instance, might help you understand whether the data are normally distributed. Here's some basic statistical measures that are reported. The mean is the same as we've seen. The median is the centermost value. The mode is the most frequent value. The range is the maximum minus the minimum. And it also reports an interquartile range, which is the 75th minus the 25th percentile. Then we have a test for location. Notice here it says mu naught equals 0. That's basically a t-test. And we'll talk more about this in the chapter on t-test. But basically you have a student's t-test, a signed test, a signed rank test, and so forth, and the p-values associated with those tests. It also reports the quantiles. So here we have a number of quantiles from the 0 or the minimum to 100% maximum. So 11 is the median value there, so we can easily see various values along the range of quantiles. It reports extreme observations. This comes in very handy sometimes because oftentimes we want to know what are the highest or lowest values in the data set, and we can see here so we have values. The value 4 is the lowest value. It's observation number 20, and 15 is the largest value. It's the observation number 36. So this often allows you to, particularly if you have some values that are way out of line, it will help you find out not only what those values are, but what observation they are, so that maybe you can go back in there if they look extremely odd or unusual. Maybe you can go back in there, double check to make sure those values are correct. All right, let's talk about using PROC univariate to assess the normality of data. And this becomes a handy thing to be able to do. And the way we do that is by requesting normal tests and plots. So here we have PROC univariate, normal, and plot. I added these two options to the PROC univariate statement. The normal and plot options produce a test for normality, a stem and leaf plot for some SAS versions, a box plot, a normal probability plot, and the histogram statement along with a normal option in addition produces a histogram and superimposed normal distribution curve. All right, so let's take a look at that example. Here's example 10.5. Open up the file called auni2.sas, and this is basically the same 50 values we saw earlier, where we have PROC univariate, and then the options normal and plot. And we see here's some of the output. Here we have a horizontal histogram, and with it on the right-hand side is a box and whiskers plot. If the data are normally distributed, we'd expect for the tails to be about equal and for the little diamond in the middle to coincide with the bar across, which is the mean and the median. The normal probability plot is a graphic with a plot of points that lie in a tight random scatter around a diagonal line. So if that's the way it occurs, a tight random scatter around this line, then again it indicates the data are probably normally distributed. There's a test for normality given, or actually several tests. Here we have the Shapiro-Wilk, Kaldrum-Ross-Smirnov, Kramer-von Mises, and Anderson-Darling test. They test they test for normality using different kinds of ways, and you might want to familiarize yourself with which tests tested in some ways. So here we have the Shapiro-Wilk gives a p-value of 0.07. Now if we use 0.05 as our cutoff point, we would say there's not enough evidence to claim non-normality. However, the Kaldrum-Ross-Smirnov test is low, 0.01, which is below 0.05, and so are the other two. So we get sort of a mixed results here, but mostly it says that the data are probably a little askew from normality. And a histogram is commonly also used to visually examine the distribution, and so we ask for that using, so normally we would say histogram age, which gives us the histogram, but if we say histogram age / normal, as we've seen in the previous example, it produces a normal plot. So here let's look at this and add in here where it says add the new statement. Let's add the statement histogram age / normal. Now this is different than the normal option that's up there in PROC univariate that produced the information we just saw. Now this one is actually going to create a histogram of age and with some normal with a normal plot here. And this is what we get. So here we have the histogram, and then superimposed on it is a normality plot. And we should normally, or typically, if the data are normally distributed, we'd expect the peak to coincide with the peak of the normal plot. So here again we see it's a little askew. Now, with a few additional commands using PROC univariate, we can break up some data into various other categories. So for instance, here we have race, white, other, and black, and we could take a look to see if there are any differences in some value that we're looking at according to race. In this case, it looks pretty similar, but this shows you how you could do that kind of thing. All right, let's look and see how that works. So here we have auni3.sas. Open up that program, and we're going to use the class race category, RACE_CAT, and we're going to just give it the label race with the variable systolic blood pressure. So we're interested, is there a difference in systolic blood pressure by race? And let's look at the histogram / normal. We're going to make it green with the width of 5, and we know that there's 3 race categories. So I'm going to tell it to display this plot with 3 rows. Now if I back up, that's what this plot is. So we show the plot first, and then this is the code that produced that plot. All right, so let's talk about formatting our output. And we've seen how formatting works before, and this is just another example of creating a format and then applying it. But basically, let's look at how we would do that. So in this case, we're going to have PROC format value, format wound. So there's 2 types of wounds in this data set. 0 is a non-penetrating wound, and 1 is a penetrating wound. So it was reported as 0 and 1, but we would prefer it with the actual word here so that we know easily which is which. We can also use a class statement, as we saw in an early example, to compare the histograms by a grouping factor. The rows and the columns, we asked for instance, 3 rows. We could have asked for 3 columns, and then it would have formatted the picture a little bit differently. We can use C-fill to specify a color fill for the histogram bars. P-fill for a scatter, to specify a pattern. Again, these are in Appendix A. You can see what all these mean. And the inset to create a key, as we've discussed also in the past. So those are ways that you can customize your histogram output. The inset command, let's dive a little bit deeper into that one. And we've mentioned it, but let's look at it more closely. So here's the inset command. So I have in, and I'm going to use the title in colon with the format 4.0, and then min with the format of 4.1, and max. So here I'm asking for 3 statistics, in, min, and max. Slash header, and I'm going to call it my key. I'm going to say no frame, so it's going to take the frame off. It's going to position it in the northeast, which would be the upper right corner, and the letters in the inset are going to have a height of 2. 1 is the default, so 2 is a little larger than what would normally be displayed. All right, and so I just discussed that, so let's move on. And let's look at how that looks in a program. So here we have AUNI4. Open that file up, and we see that we created the format called FMT wound, and we are then doing a PROC format. And notice how down at the bottom we're applying that format wound, FMT wound. Now what this is going to do is when we look at the various classes, it's going to give us these non-penetrate and penetrate labels instead of 0 and 1. And then we already discussed the contents of the inset command. All right, so finally, here is what we get. Notice on the far left we get penetrate and non-penetrate. That's broken up as we asked. Gender already was noted as female and male. We see the histogram, the 4 histograms then that are represented by these 4 groups. And notice the inset that was created, where we have in, min, and max, the 3 statistics that were requested. Now there's some additional options in this hands-on example, and I encourage you to do those in the text. Okay, that brings us to our summary of this chapter, where we learned to use PROC means and PROC univariate, and in particular how to create histograms and evaluate the normality of data using PROC univariate. We're going to continue to Chapter 11, Analyzing Counts and Tables. Thank you for watching. If this was helpful to you, we appreciate you liking and subscribing to this channel. Thanks.